Time to take a tour of Mercury as we begin our study of planets in the solar system. Well, Mercury is interesting in that it's been visited recently by a spacecraft that's still in orbit around Mercury as of 2014 and has provided us a lot of new views of the surface of Mercury that were not available before. Remember our tour of the solar system. Mercury is our planet that's closest to the Sun. Again, this slide does not give correct spacing of planets, but correct size. So you can see Mercury is the smallest of the terrestrial planets. Again, Mercury up here compared to the other planets and in an orbit that's close to the Sun. And here we have just the terrestrial planets image for us. And a little curious here, what's going on with Mercury in this slice? Well, what's going on? This is image from 1974. And in 1974, the spacecraft that flew by Mercury did not give complete coverage of the surface. That's been remedied now with the Messenger Spacecraft that flew by Mercury in 2008 and subsequently went into orbit in 2011. Mercury has an interesting rotation in that it rotates 3 times on its axis for every 2 orbits around the Sun. Though it's not quite a tidal lock. Mercury does not have the same face of the planet towards the Sun all the time, but there is a kind of a resonance in the rotation. If we study this here in this diagram, so we put a post in Mercury and face it away from the Sun, call that position 1. At position 2, we're half of rotation of the planet. We're here about 1/3 of the way around the orbit, and there's one rotation of the planet, position 3. Our post is again pointed towards the top of the screen. Then position 4, another 1/3 of our orbit, we're towards the Sun. Position 5, there's the second rotation of Mercury. Position 6, and then finally position 7 is back to, again, having the post towards the top of the page. So hopefully you're following that, or try it on your own. Mercury makes 3 rotations every 2 orbits. A little animation of this. Again, the arrow was pointed up at the start. So 1 rotation, 2 rotations, 3 rotations. So 3 rotations in 2 orbits. Mercury has what you might call a day, a length of time for 1 spin of the axis of 59 days, an orbit around the Sun of 88 days. It does turn out that the Sun is above the horizon for 88 days and below the horizon for 88 days. You might try to confirm that with the diagrams. As far as seeing Mercury in the sky, it is difficult because it's close to the Sun, and the Sun is not as big as the gray disk here. Just a little point in the middle here. Because the Mercury's orbit is close to the Sun, Mercury does not get very far away from the Sun. So in 2013, there was a nice configuration of Mercury in October. Just kind of watch the Mercury move along here. October 9th, October 16th, October 23rd. So we were at a bigger angle back here for seeing Mercury. That was the best. And then October 30th, Mercury is getting very near the Sun and not easily viewed. November 6th, actually, Mercury's moved to the right side to become a morning object. So here we are in 2014, and Mercury is not in a good view here, being aligned with the Sun. But to watch what happens, Mercury is a fast-moving planet. October 24th, October 31st, and here we would have a reasonably good chance of seeing Mercury. It's to the right of the Sun. Does that make it a morning object or an evening object if it's to the right of the Sun? Which rises first, viewed from Earth? Will the Sun rise first, or will Mercury rise first? And you should say Mercury will rise first. It's to the right of the Sun. When the Sun is on the eastern horizon, Mercury is to the right of it. It's already up in the sky. So if you want to, early in the morning, October 31st, November 1st, would be a good time to view Mercury. So in 2008, when the Messenger spacecraft flew by, we took these photos. Mercury has been studied in the past long range from Earth, and again the spacecraft that flew by in 1974. But we can measure temperatures on Mercury. Mercury is close to the Sun, extremely thin atmosphere, almost no atmosphere. But high temperature on Mercury in the sunlight, about 825 degrees Fahrenheit. 825 degrees Fahrenheit. Then on the backside, away from the Sun in this picture, we would have very cold temperatures, no atmosphere blanket to hold in the heat, so about minus 280 degrees Fahrenheit. So the swing in temperatures, if you were standing on Mercury, you'd have to be prepared to survive going from 825 degrees Fahrenheit when you're in sunlight to minus 280 degrees Fahrenheit when you're away from the Sun. Mercury's size, it's about a third of the size of the Earth. It is bigger than our moon by about 30%, so it still fits into the planet category. But our first flyby of Mercury in 1974, and again we have this kind of resonance in the motion of the rotation of Mercury and the orbit of Mercury. I want to talk about this 2008 picture. This is the Messenger spacecraft that flew by Mercury in 2008. Its goal was to orbit. Why didn't it orbit the first time passed? Why did the orbiting wait till 2011? Well, if you'd think of dropping something in space, away from the Earth, but just release it, the Sun's gravity is going to pull it towards the Sun, and it's going to speed up. Same thing happens with spacecraft launched from the Earth, headed towards Mercury. As they move towards the Sun's gravity speeds them up. And then Mercury's gravity is not very strong to capture something that flies by Mercury. So the orbit of the Messenger spacecraft was carefully plotted out. As the spacecraft went by Mercury, it went by in such a way that Mercury's gravity slowed it down a little bit. And then it went past Venus, and Venus gravity slowed the spacecraft down a little bit. And then went by Mercury and it slowed down, but finally went into orbit in 2011. So here's an interesting picture from 2009, the flyby. And you see these long rays, and it's believed that these are debris, streaks of debris from a crater that had not been imaged before, the Messenger spacecraft. Long streaks of debris across the planet. You can see other rays going out from impact craters. And again, because Mercury has almost no atmosphere and no weather, there's no erosion, so these craters are visible for a long time. We just have erosion of other impacts that deal with wiping out old craters. So that's not a very great erosion. Mercury is interesting for the names of the features on the planets. You should take a look at these and check out your humanities background with musicians and artists that from various countries around the world. It's sort of the tradition of naming features on Mercury. So up here, Bronte, Burns, Hagen, Vivaldi, and other very capable artists, I'm sure, for these other crater names. And here's the region that wasn't imaged before when the spacecraft went by in 1974. But lots of craters being named now, lots of opportunity for artists to be recognized on the planet Mercury. Again, impacts, and they strike the surface, they dig out material. This is the floor, this is lower than the average terrain level, and some of that debris is visible. You can see sort of clouds of debris, these rays that have fallen on Mercury away from the main crater. There are large basins where in the early history of the solar system there were more powerful impacts, and these flattened a wider area and left a bigger depression. So one of these is the Rembrandt Basin. The Caloris Basin, and this is color-enhanced photography revealing the types of minerals that are present on Mercury. And this is considerable, 960 miles in diameter for the basin here. There's some interesting cracks near the center of of this basin. Here's a crater that left a double ring. It's kind of a rebounding material of rock, left a double ring pattern. And Mercury has ridges and cliffs. You can see the shadowing here with the sun off to the right. How do I know the sun is off to the right? Well, look at the craters. The shadow is near this edge of the crater, this slope of the craters in sunlight. So the sun is off to your right, and you can see these shadows from these cliffs. It's thought that all the planets were hotter when they first formed, more molten material on the planet. And as it cooled, the material would shrink. The planet would shrink a little bit. And that caused stresses on the crust of the planet, and it buckled and formed these cliffs and ridges as part of the cooling process for the planet. Another illustration of this, a long cliff running along here. There are old volcanic vents visible on Mercury. Again, the dome here has an elevation above the average terrain, and then vents that are visible where lava came out in the past, in the early history of Mercury. Don't think there are any active volcanoes now on Mercury, but in the past there was some volcanic activity. And very recently, at least when this video has been made, this Messenger spacecraft, one of the photographs has been enhanced, so overexposed here, but looking at the deep inside this crater near the North Pole, Mercury spins on its axis straight up and down compared to its orbit. It's not tilted. The Earth is tilted 23.5 degrees for its spin axis, but Mercury is not tilted, and there are deep craters at the North and South Pole that never receive sunlight, and this is an image of water ice that is at the bottom of this crater. So the Messenger spacecraft giving us confirmation of what radar had already proposed, and that there's water ice in the base and the bottoms of these very deep craters. So an interesting feature. So how would Mercury and the Moon differ? This is Mercury. Well, material that's splashed out of the craters on Mercury does not go as far. So there's more smooth area on Mercury compared to the Moon. The craters that formed on the Moon blast rocks out, and they kind of make rough terrain for a wider area. So that's one element. Another big difference would be the density. Mercury is more dense than the Moon, almost as dense as the Earth. And that's surprising because Mercury doesn't have enough mass to compress its interior very much. But Mercury is very dense, and it is believed that Mercury has much more metals than, as a fraction, than the Earth. It's denser due to its construction, its composition, not to its compression, its pressure on the inside. But Mercury has more metals than the other terrestrial planets, or the Jovian planets, as a percentage. It's believed that this core is perhaps 80% of the planet. It's a huge core compared to, as a percentage, compared to the other terrestrial planets. It's also believed that there's some liquid material in this core, because Mercury does have a magnetic field. Although it's quite a bit weaker than the Earth's magnetic field, there is a global magnetic field for Mercury. Going with the dynamo theory, that implies that there's liquid material, and there's some evidence from the types of motions the planet has that there is liquid material in the core of Mercury. So an interesting fact about Mercury, and though it's a little bit surprising that there's still liquid there after many years since its formation. I think that might have cooled off. So some other things about the surface of Mercury. The cliffs I showed you are a few miles high, and they can be 60 miles long. The strength of Mercury's magnetic field, about 1% of the value of the Earth's. The Mercury's density, 5.44 grams per cubic centimeter. The Earth, 5.52, so it's very equal, nearly equal to the density of the Earth. Water is 1 gram per cubic centimeter, so we have something more dense than rock. Another interesting thing about Mercury is its orbit. Its perihelion position shifts rather rapidly compared to the other planets. And this became a mystery in the 1800s. Some people proposed that there was another planet inside the orbit of Mercury, that the gravitational pull of this other planet was disturbing the orbit of Mercury, such that its perihelion position would change rapidly. But a better explanation came in the early 1900s when Einstein proposed that the Sun warps space, bends space, and that actually creates the effect of gravity. In fact, this is the accepted view now, and it fully explained the motion of Mercury's orbit and why it shifts around the perihelion position. This warping of space model correctly predicts the shifting of Mercury's orbit. And in a sense, the Sun is warping space, and the planets are going around the Sun on a banked track, banked space, something like NASCAR cars go around a track with the help of the banking. So very interesting. Mercury has played a role in helping us understand gravity a little bit better. So there we have our innermost planet. Very hostile in terms of temperatures, hard to get to because things speed up when they move towards the Sun. So a more complicated trajectory of the spacecraft has to be used to put something in orbit around Mercury. Interesting for long rays, long cliffs, and interesting names of craters for the humanities, arts, and writers, musicians, being honored by having their name attached to a crater on Mercury. So you should keep reading and ask questions.